Okay, I'm very glad that you asked about this problem because this was a great problem to see if you're really getting what's going on or if you are kind of following an algorithm and kind of memorized a pattern but don't really understand what you're doing. So what I want you to do is read the problem very carefully and try to say, you know, listen for words that are like derivative, listen for rate of change, listen for those types of things. Okay, and you'll notice right here at the end, if you've paused the video and read it and read the problem and checked it out, you'll notice right here at the end it says find the rate of increase of research papers per government subsidy dollar. So when we hear rate of change, derivative, so we're trying to find the change in research papers. So which variable represents research papers? That variable would be P. Right? Whoops, that's not what I meant to do, excuse me. That variable would be P, the annual number of groundbreaking research papers. So change in P per, now it wants it per government subsidy dollar. So now which variable is that? What I'm seeing here is Z. Z is not the annual foundation subsidy to the laboratory. So therefore we're going to do change in Z. So what this problem is literally saying is just find the partial derivative of P with respect to Z with this given information. So with a, let's see, subsidy level of $1 million per year and a staff level of 10 physicists and an annual budget of $100,000. So X is the number of physicists. We have 10. So take the derivative, evaluate at 10. And then Y is the laboratory's annual research, so that would be $100,000. Can't use commas because that would be a little confusing. And then again, subsidy of $1 million, one more zero, I believe. There we go. So there you go. Take the partial derivative of this function of P with respect to Z, then evaluate it at those values. That's all the problem's asking you to do. So if that's what you had tried in the past, fantastic. You understand what's going on. You get the big idea. It was probably just something weird in the derivative that caught you. If you didn't catch that, really go back and make sure you understand that thought process. We're listening for rate of increase, rate of change per something. It goes right back to the brief calculus, and hearing that derivative. And then writing it out. Here we just have more choices instead of just a derivative of one variable, which made pre-calculus easy. Now we have multiple variables, so it's, or not pre-calculus, excuse me, brief calculus made it easier because it was very laid out. The plan was very laid out. Here you have three choices and you have to listen to the words to decide which one you're doing the derivative with respect to. Let me know if you need more.